All right, let's just jump right in. Today we're talking about the most powerful, and you could argue the most important force in the entire universe. It's the invisible glue that holds reality itself together.
So I want you to imagine something for just a split second. What if this force just blinked out of existence, switched off? The very first thing that would happen is this. Yep, you heard that right. Every single atom in your body, in the planet, in the sun, would instantly disintegrate. Stars would just explode.
And reality as we know it would simply cease to be. Nothing would be left. That is the kind of power we're dealing with here.
To really get a handle on this force, we first have to appreciate the absolutely massive problem it solves. It's a paradox at the very heart of all matter.
Okay, so let's zoom way in, past the electrons, deep down into the core of an atom. You find the nucleus, this incredibly crowded little space, packed with protons and neutrons. But there's a problem, a really big one. Think back to your high school physics class. Like charges repel each other, and all those protons crammed together, they're all positively charged. The laws of electromagnetism say they should be pushing each other apart with an unbelievable amount of force. The atomic nucleus should be the most unstable thing in the universe. It should just fly apart instantly, but it doesn't. So what's holding it all together?
Well, that something is one of the four fundamental forces of nature. And it's the one that basically puts all the others to shame.
What's just insane to see on this chart is the scale. I mean, we think of gravity as being powerful, right? It holds entire galaxies together. But compared to the strong force, gravity is, well, it's practically zero. The strong force is about 100 times stronger than electromagnetism, the force that makes magnets work. And get this, it's 100 trillion times stronger than gravity. It's not even playing the same sport, let alone in the same league.
So what is its job? Well, not only does it hold the protons and neutrons together inside the nucleus, it actually works on an even deeper level. It's the force that literally builds the protons and neutrons to begin with by binding even smaller particles called quarks. To see how that works, we've got to go deeper still. We need to look right inside the proton itself. So for quarks to interact with the strong force, they have a property that physicists pretty cleverly called color charge. Now, let's be super clear, this has absolutely nothing to do with actual color that we see. It's just a handy analogy. Kind of like how combining red, green, and blue light gives you white light, combining the three color charges gives you a color-neutral particle. And that's a fundamental rule for any particle that can exist on its own.
And the particles that carry this force? They're called gluons. Perfect name, right? They are literally the glue. They are constantly zipping back and forth between quarks, swapping their colored charges around. It's this chaotic, non-stop exchange that creates the incredible binding force. Just try to picture this swirling sea of energy inside every single proton.
And this is where the rules of the strong force get really weird, and completely unlike any other force we're used to. This slide really captures the force's main paradox. When quarks are squeezed super close together, the force between them gets really weak. They can kind of just move around freely. Physicists call this asymptotic freedom. But the moment you try to pull them apart, something wild happens. The force gets stronger the farther apart they get. It's like a cosmic rubber band. The more you stretch it, the harder it snaps back.
Now, if you pull on that cosmic rubber band with enough energy to try and break it, it doesn't break. Instead, all that energy you just poured in gets converted into creating a brand new pair of quarks out of thin air. The result? You can never, ever isolate a single quark. They are permanently locked up or confined inside larger particles.
But this force isn't always all-powerful. In really big, unstable atoms, you have dozens and dozens of protons all trying to push away from each other. That combined electrical repulsion can actually start to overwhelm the strong force's grip. And that's exactly what radioactivity is. It's the sound of the strong force losing a battle in this constant cosmic tug-of-war.
So this incredible binding force doesn't just hold things together. It also stores an absolutely staggering amount of energy.
We call this nuclear binding energy. When you either fuse light atoms together, which is what happens in stars, or you split heavy ones apart in a nuclear reactor, a tiny fraction of their mass gets converted into a massive release of that stored energy. This is the very energy that powers our sun and every star in the sky.
So the next time you see Einstein's famous equation, E equals mc squared, don't just think of it as some abstract concept. It is the direct result of the strong force in action. It's the recipe for converting the mass that's locked away by this force into pure raw energy. It is the power of our sun and the devastating force of atomic weapons.
Okay, so let's pull all the way back out. Because this force didn't just build atoms, it laid the very foundation for the entire cosmos.
In the very first moments after the Big Bang, the universe was just this incredibly hot soup of free-floating quarks and gluons. But as the universe cooled just a tiny bit, the strong force kicked in and it corralled all those particles into the very first protons and neutrons. Without that step, nothing else we see today could have happened. No atoms, no stars, no galaxies.
And here is the truly mind-boggling part. The strength of this force is tuned with unbelievable precision. If it were just a tiny bit weaker, protons and neutrons couldn't form stable nuclei. Just a tiny bit stronger, and all the hydrogen would have fused into heavier elements right after the Big Bang, leaving no fuel for future stars. Our entire existence is balanced on this cosmic knife's edge.
So, every breath you take, every object you see, every single star in the night sky, it all exists because of this silent, impossibly powerful force operating at a scale we can barely imagine, constantly weaving our world together.
It really makes you wonder, doesn't it? The strong force is just one of the 4 fundamental rules we figured out. What other invisible architecture is out there, quietly shaping the universe all around us?